So, which is the graph of this function? So I'm going to rewrite this in a slightly different form, and when I do this also, I don't like using the variable t. It confuses me. It looks like a plus sign sometimes. So I'm just going to use x like we normally do, like all good people should. So this, I'm going to write this as y equals 1/4 tangent. And then, so here it says 1/9 pi, which is the same thing as pi over 9. I'm just going to prefer to write it that way. Okay, and I'm going to put x. All right, so a couple of things. First of all, let's remember what the parent function of tangent looks like. Okay, so here comes the parent function of tangent. You should write this down, by the way. Everything I'm writing, you should write this down. So first of all, one period of the tangent function is pi. Okay, unlike sine and cosine, which go 2 pi, one period of the tangent function has the length of pi. Alright, so there'll be pi, and then this will be pi over 2, which would make this pi over, I'm not even going to label this. That's enough. So I have pi over 2 and I have pi, and I'll just put some marks in between for guidelines. Okay, and I will put a 1 and a -1. So the thing about the tangent function is that it begins and ends on the x-axis. Right in the middle there's an asymptote. So there's an asymptote right here. Now the tangent function is always increasing from left to right. So it's going to approach the tangent function. And by the way, at this first mark, it should be at a height of 1. So it's going to go through that point and it's going to approach the asymptote. And on the other side of the asymptote, it's still going to be rising. At this mark right here, at the halfway point, it should be down 1. So it's going to pass through that point on its way back to the x-axis. Okay, so this is what one period of the tangent function looks like without any modifications. Now, I'm going to go ahead and make another period of it. So that would make this negative pi. And right here we'd have negative pi over 2. I'll put an extra couple marks here and here. So it's just going to be the same thing repeated. So again, there should be an asymptote right here in the middle of the period. And again, tangent begins and ends on the x-axis. And it should pass through this point. It should pass through this point. And of course it has to approach the asymptote. Okay, so this is what two periods of the tangent function would look like. Now, so the only question is, how will this be affected by the two transformations that we see? The a value and this b value. Well, the a value is just going to change this sort of guide point. Right here where I kept saying at this mark it's going to be at 1, and at this mark it'll be at -1. So instead of 1 and -1, because of this a value of 1/4, then this should be 1/4 and -1/4. Okay, so I don't really have to change the graph for that. Now, how will the b value change things? Well, this b value affects the period of the function because of the following formula. We know that the period is equal to the normal period, which is pi, divided by the b value. So the period is going to be pi divided by pi over 9. Okay, well, how do you divide by a fraction? Well, hopefully you learned years ago that you need to multiply by the reciprocal. So this would be the same thing as pi times 9 over pi. And then these pi's are going to cancel out, so that leaves you with a period of 9. Okay, this is key information to help us narrow down our choices. So the period, instead of pi, is going to be 9. So I'm just going to go back and erase all my little numbers to reflect that. So here's the key. Instead of pi, this should be 9 and negative 9. So basically we're looking for this graph. So for starters, we can look for a graph that begins and ends at negative 9 and positive 9. All right. Well, it looks like these graphs don't extend all the way to negative 9 and positive 9, like they're being cut off. It goes off the grid. So we'll have to use the numbers that we have. So let me go ahead and add in the asymptote. So obviously if this is 9, then halfway would be 4.5. So that's where the asymptote is, 4.5 and negative 4.5. So because these graphs only go to negative 5 and positive 5, then we'll have to use the asymptotes instead of the endpoints, but it should still be okay. Alright, so we're looking for graphs that have asymptotes at negative 4.5 and positive 4.5. Let's go ahead and throw this graph right here out immediately. It's the one graph that is not increasing. Remember that tangent is increasing. As we go from left to right, this is increasing, increasing, increasing. Every portion is increasing. But looking at this one particular option, all of these branches are decreasing. They're all going downhill from left to right. So that's definitely not it. Okay. Now, this is a little bit hard to see. Maybe I'll zoom in a bunch. Okay, it seems to me that the way they are marking the graph, every one of these marks is actually half of a unit. So, for example, this is 1, and this is 2, and this is 3, and this is 4, and then they've given us 5. So the asymptote should be right here at 4.5. Okay, and that looks fairly close, but see how this is intersecting with the graph? So this is not quite it. Look at the other side. So this would be negative 1 and negative 2 and negative 3 and negative 4. So again, the asymptote should be here at negative 4.5. But you can see that the graph crosses that. The graph touches that line. So that tells me that this is not the answer. So I'm going to go ahead and throw this out. Okay, so let's go ahead and look at the next one. Does this one have the asymptote in the right place? So one more time, this is 1, 2, 3, 4. Alright, so 4.5 is right here. So this is even worse than the last one. Okay, so that clearly is not where the asymptote is. Alright, the asymptote of this graph is way over here somewhere. So C is not the right answer. Okay, that just leaves D. So hopefully this is going to match. And so here's 4.5 right here, and if we draw this asymptote, you can see that it does match. Okay, and over here would be negative 4.5. So if we put the asymptote over here, you can see that the graph approaches that line nicely. So the correct answer is D. And let's just check our answer. And there you go.